Hello everyone. Welcome back to the second video session or problem session of fourth week. So due to some technical errors, not able to upload the remaining one problem. So now I am just solving problem 3, how it can be solved. So let's get into the fourth problem. Third problem. So last class we have seen the up to third second problem. So what's the importance of cross coefficient? What's the importance of main coefficient? So how this concentration profiles have been has been read completely. So if you move from left to right, the concentration gradient, if it is reducing, it is moving from left to right, then the concentration gradient is negative, because if you consider this point and this point, if you take the slope of this one at one particular this point, it will be a negative value. Dc by dx is negative value. C2 minus C1 divided by x2 minus x1 will be a negative value when the concentration profile of a second component, if it is moving from right to left, if it is decreasing from right to left, but we are moving in the opposite direction, then its concentration profile is positive. So this is, and what's the importance of a cross coefficient and what's the importance of a main coefficient, I've been also studied, and what's the importance of these things are studied, analyzed in the last previous videos. For this one, you just for complete analysis or complete visualization, you can see a previous video which is given in the link in the descriptions below also. And let's get into the third problem. So partially I have solved this one during the problem section itself. So for recording, I'm just doing this one. So first, he has I'll read the question. That is, a diffusion coefficient of a zinc in a copper at a 500 degrees Celsius and a 1000 degrees Celsius are given as shown. 400 10 minus 18, 500 10 minus 13. So there is a lot of differences between the diffusion coefficients when there is when we increase the double, it increases the temperature. That is, when he increases the doubles the temperature. So 5 times it has been increased. So determine the approximate time at 500 degrees Celsius that will produce the same result, same diffusion results as the 10 hours of heat treatment at 1000 degrees Celsius. So what he is saying is, so we are carrying out a one diffusion couple experiment. I will explain completely. See, this diffusion couple experiment is there. This side it's copper, this side zinc, Zn. So, so if we carry out the process 10 hours at 1000 degrees Celsius, it produces some diffusion depth. Up to here, it will produce, see, up to here, example. So for example, it is 200 micron. So to produce the same diffusion depth, so to produce the same diffusion depth, this is at 1000 degrees Celsius and this is at 500 degrees Celsius. Okay, so to produce the same diffusion depth in the same diffusion couple, so what will be the time taken? So here it is taken 10 hours, but how much time does it will take to produce a 200 micron of diffusion depth? So for example, he has given at 500 degrees Celsius 400 micron minus 18, and whereas at 1000 degrees Celsius, is it possible to okay, can't possible. So at 1000 degrees Celsius, the 5 into 10 to the minus 18. I have given a hint as dt is equals to constant. So dt is equals to constant means so to produce dt is equals to constant. Yes, what I'm saying, yeah. So I given a hint as dt is equals to constant. So we have to consider dt at 500 degrees Celsius temperature that I am writing here. dt is equals to 1000. So here uh, d means diffusion coefficient, t is the time. So directly we can substitute the values of this one at 500 degrees Celsius. The diffusion coefficient is very less, 10 to the power of minus 18 into t value. So we have a diffusion coefficient at 1000 degrees Celsius, 5 into 10 to the power minus 13. So he has given the time as 10 hours. So we will write it as in 10 hours itself. So you can ask one doubt, simple doubt here. So diffusion coefficients are in seconds. So how can you write 10 as in hours? Because so we are dividing this. So I'll write it one more step that will be clear for you. 5 into 10 to the power minus 13. Sorry for this one. So here it is minus 13 divided by 4 into 10 to the power minus 18 into 10, right? So 4 5 by 4, so just calculate this one. It is 1.25, 1.25 into 10 to the power of 5 into 10, that means it will be 6. S, yeah, hours. See, so why I have considered I have not converted this into hours means we are dividing a meter square by second to meter square by second, that will cancels out and we'll get directly hours. So this is the correct answer. So what is the output that you will get from this one? What is the output that you will get from this one? To produce 200 microns, temperature is a significant parameter. Temperature is a significant parameter for the diffusion. So if you just reduce the temperature by half, that is 500 degrees Celsius, to produce this 1200 microns, it will take several hours. So if you want to convert this one into days, divided by 24, it will take almost infinite, like 52,084 days almost. So which is for doing a heat treatment of this many hours is highly impossible. So if you have a data at 1000 degrees Celsius, so you can analyze. So at 900 degrees Celsius, how much it will take? At 1100 degrees Celsius, how much it will take? So for example, I will give one this. I don't know exact. We don't know exact value of right now. In data we have, you just find the d value at 1100 degrees Celsius. So it may be a lesser, so higher than this one. Maybe for example 6.2 into 10 to the power of minus 11 or 12 maybe. So you just do this for calculation. So you will get directly, you will get the how much hours or how much second you will get to take the. So for example, if it is having 6.2 into 10 power minus 11, so it will take, how much it will take? 5 divided by 6.2 first of all, and into, sorry, divided by 100, yes, into 10. So yeah, so it will take t is equals to 0.08 hours if you increases the temperature by 1100 degrees Celsius. See, so if you want to convert this one into, it will take only 290 seconds. So this is the how the diffusion coefficient value as well as the temperature affects the diffusion phenomena. So thank you. We will see in the next video lecture.